In this presentation, we're going to talk about a logical statement called a conditional statement. And this one is particularly important to us because it's used all the time throughout, almost really every branch of mathematics. It has this kind of basic shape that you see in the example I have here. It starts off with if, then it has a logical statement, then the word then, and then another logical statement. And the way we write this is just kind of following the same pattern we've used for our other logical statements. We replace the two kind of sub-statements, the it's raining and I am wet, with variables, P and Q. And then we have a symbol to represent the if-then part, and that's this arrow that you see here. And this is read two ways. You'll hear it read if P, then Q, and you'll sometimes hear people say P implies Q. That's kind of a misstatement. It isn't really what's going on here logically, but it's extremely popular, so you're definitely going to hear that relatively often. So four more definitions that you should be aware of, and these are just labels. The P part of this statement is sometimes referred to as the hypothesis or the antecedent, and the Q part is sometimes referred to as either the conclusion or the consequent. Those are kind of, I don't know what the word for it is. They're names that you don't hear used very often, but they do come up. So you should just have them in the back of your mind. So now that we have those labels out of the way, let's do what we've done for every other kind of logical statement we've looked at. We need to have a truth table so that we can evaluate this thing and use it in comparison to other logical statements and so forth, like we've done with everything else we've seen so far. So I've written out the truth table here, and I've done this the same way we always have. I have all the possible values of P and Q, and I copied those values into the P column and the Q column. So what we need to do now is figure out what's going on in the middle, what this logical statement evaluates to for different values. So to do this, I've put an example up here, an English example for us to work with. If it's raining, then I'm wet. And what this is saying, if we just think about the English for a minute, is if you look outside and it's raining, then you can be absolutely certain that I'm wet. So if both of these statements are true, then the original statement is true. Now, let's look at this second one. If it's raining outside and I am not wet, that's the situation where this statement is false. This statement tells you what's happening if it's raining. If there's water falling from the sky, then you can tell for certain that I am going to be wet. And if I'm not, then there's a problem, and there's something false about the original statement. Now, these last two are the ones where students sometimes run into trouble. What happens if the first statement is false? All right, this is the part where you need to think like a mathematician, and you need to be extremely literal. You can't read into the statement. You can't infer things from the statement. You have to go by what it tells you and nothing else. This statement tells you what has to be true in the event that it's raining. It tells you nothing about what's going to happen if it's not raining. So if it's not raining, is it possible that I'm wet? Yeah, I could be wet for some other reason. So this is a true statement. And if it's raining, is it possible that I'm not wet? Well, possibly yes. This statement is also true. So these last two lines here, in interpreting these, what you need to understand is this statement tells you nothing about the situation where it's not raining. If it's not raining, it's possible for the consequent, remember that's this side here, it's possible for the consequent to be true, and it's possible for it not to be true. The original statement doesn't give us any information to work with. Okay, so I have here a truth table for us to practice with, and there's nothing particularly significant about this relationship. This is just kind of purely for practice. So what I have here is this situation. I have P or Q implies not P. And I want to evaluate the truth table for this statement. So I've done this in the usual way. I have P and Q here, all of our possible combinations. And I've copied P and Q into the various columns. So now what I'm going to do is I'm going to do it the way we've always done this. I'm going to start filling things in, kind of following our order of operations. And speaking of that order, we have a new symbol here, right? We have this implication, this conditional. Conditionals in our order come last. So that this makes our order parentheses come first, then negations, then ors and ands, and finally at the very end we do conditionals. So with our statement here, I'm going to start with the parentheses, which means doing this or. And you remember an or is false only when both of the inputs are false. So I have two falses down here. This row is going to be false, and everybody else is going to be true. Then for the negation, that just reverses the values of everybody that comes after it. And now to do the conditional here, I'm going to kind of disregard the inputs now. And I'm going to just look at the two result columns. And if you think back to the truth table we did on the previous slide, the only time this conditional evaluates to false is when we have true in the first column and false in the second. So I'm going to kind of scan down my list here, and I see that I have two rows where I have a true and then a false. So these two are false, and the remaining two are true. So this is the end result, the final value of our truth table. So we have a mix here. This is neither a syllogism nor a contradiction. It's just kind of a random statement. There are times when it's true and times when it's false. So in our next presentation, we're going to look at some variations on a conditional statement. We're going to look at the conditional, the converse, the inverse, and the contrapositive. And those three statements are all derived from the conditional. And we'll look at statements where they're equivalent to a conditional, and see some of them are equivalent, some of them are not, and we'll see which ones are which.